Welcome back for another deep dive. Today, we're going to be looking at something you might not have even considered.
Oh, yeah.
Yeah, it's about how semiconductor plants can accidentally pollute their own fresh air intakes.
Interesting.
It is really interesting. You know, they have those super clean rooms
Yeah.
where they have to make the chips.
Mm.
Well, it turns out that that clean air that they're pumping in
Right.
can sometimes be contaminated with their own,
With their own exhausts.
yeah, their own exhaust, basically.
Yeah, it really highlights just how, even with, cutting edge technology, seemingly simple things can have major consequences.
Absolutely. And you sent over this research article, which
Oh, yeah?
used some seriously high-tech simulations to study this.
It was really fascinating.
Yeah, and it had some interesting findings.
For sure. We should break down the science, but then also think about the bigger picture, too.
Okay.
Like, what does this mean for cleaner manufacturing?
Right.
And, this is something that obviously goes way beyond just computer chips.
Oh, absolutely.
Yeah.
So this study focused on a specific plant in Taiwan, which, as you know, is a huge player in the semiconductor world.
Right.
What exactly were they looking at in this study?
Well, they focused on common pollutants like ammonia, hydrofluoric acid, and then also those volatile organic compounds.
Right, TVOCs.
Exactly.
Not exactly things you want around delicate electronics.
No, not at all. And they are released from chimneys, which you would think would carry them away. But
Right.
here's where it gets interesting. The plant also has these things called makeup air units,
Okay.
or MAUs for short.
All right.
They're on the roofs, and they basically pull in fresh air.
So it keeps the clean room spotless.
Exactly.
So wait, are you saying that the pollutants from the chimneys can get sucked right back into the plant?
That's exactly what the researchers found.
Oh, wow.
It all depends on which way the wind's blowing, how the buildings are arranged.
Okay.
Even the time of day makes a difference.
Oh, really?
Yeah, some of those pollutants were getting pulled right back into the plant through the MAUs.
Yeah.
It's almost like the plant was sabotaging itself.
Okay, now that is a surprise.
Yeah.
So you mentioned the time of day playing a role. What does that have to do with anything?
Well, the study found that solar radiation actually heats up the buildings, and that changes the air currents around them. Sometimes it can even make the pollution problem worse.
Really?
Especially in winter.
Wow. Who knew sunshine could have such a dark side? So how do you fix a problem like this? Did the researchers have any ideas?
They did. They came up with this thing called entrainer airstreams, or EAS for short.
EAS. Okay.
And basically, you can think of them as like jets of air that disrupt the flow of those pollutants.
So it stops those pollutants from being pulled into the MAUs.
Yeah, that's the idea. It's like creating a shield around those intakes.
Hmm.
But instead of a solid barrier, it's like manipulated airflow.
So I'm picturing like a force field against bad air. So how do they work? Is it just like blasting air at random?
No, not at all. Placement is key here.
Okay.
The researchers used their simulations to figure out the exact best spots for these airstreams.
So they had to take into account.
Oh, all kinds of things.
Like what?
Typical wind directions, how high the buildings and chimneys were,
Okay.
even what specific pollutants they were dealing with.
Oh, wow. So it's like a puzzle almost.
It is. It's all about figuring out the right moves to redirect those pollutants and make sure they don't reach those fresh air intakes.
So it's like air traffic control, but for pollution.
Exactly. You're creating a virtual barrier there. And those simulations actually showed that these entrainer airstreams could completely eliminate the pollution in a lot of cases.
That's incredible. It's amazing that something as simple as, strategically placed airstreams can have such a big impact. What does all this mean for the future of semiconductor manufacturing?
Well, for one, I think it's a wake-up call for the industry. Even in these highly controlled environments, you can't just assume the fresh air is going to be clean. You know what I mean?
Right. Yeah.
They really need to think carefully about the building design, the airflow patterns, and where that pollution might be coming from.
So is this research something they could use to prevent this problem in future plants?
Absolutely. These simulations are a powerful tool. Engineers can actually use them to test different designs and scenarios before they even start construction.
This is like a virtual pollution test.
Exactly. They can spot problems and figure out solutions before they even break ground on a new facility.
Wow, that makes a lot of sense.
Uh-huh.
But this goes beyond just semiconductor plants, right? I mean, there are a lot of industries that deal with pollution.
You're absolutely right. This research has implications for any industrial setting where pollution control is a concern. Think like power plants, chemical processing facilities, factories, the list goes on.
Yeah, so this could be a game changer for cleaner manufacturing across the board.
It really could, and here's where it gets even more interesting. This approach could actually have applications in urban environments, too.
In cities, how would that work?
Well, think about all the sources of pollution you have in a city.
Yeah.
Traffic congestion, industrial emissions, even just the heat coming off buildings.
Right.
All of these contribute to air quality problems.
So you're saying you could use these entrainer airstreams to, like, clean up the air in cities?
It's definitely worth looking into. Imagine using these airstreams to create cleaner breathing corridors or redirect that pollution away from schools and hospitals.
Wow. That is a fascinating idea. It's amazing to think that a solution designed for, a very specialized industry like this could have such far-reaching applications.
Yeah.
This research has given us a lot to think about. But like with any new technology, we need to consider the limitations, right? There's always a but, though, right? Like, what are the limitations of this research?
Well, you have to remember that these simulations were based on a very specific plant in Taiwan.
So what works there might not work everywhere else.
Exactly.
Wow.
Other plants might have different layouts, different climates,
Okay.
different types of pollution they're dealing with. It's not a one-size-fits-all solution.
That makes sense. And even if it did work, wouldn't it be like a huge project to actually install these systems?
Yeah, that's a good point. Implementing these entrainer airstreams would mean building new infrastructure,
Right.
which takes time and money. And then there's a cost of the energy to actually run these systems and keep them maintained.
Yeah.
All things that those plant operators would have to consider.
Yeah. It makes me wonder, too, if the simulations can really capture everything that might happen in the real world.
Yeah, that's a great point. Simulations are great tools, but they can only take us so far,
Yeah.
You can't program in every single variable.
So things like, unexpected weather changes,
Yeah.
variations in the pollutants from day to day,
For sure.
even traffic patterns around the plant could impact how well these systems work.
Precisely. Real-world testing is crucial. We need to see how these things perform under all sorts of conditions before we can really be sure they're going to be effective.
So it sounds like there's still a lot to learn.
Always. But even with these limitations, this research is a big step forward. It gives us a much better understanding of how we can control pollution in industrial settings and how we can use design to minimize those unintended consequences.
And it opens up some exciting possibilities for the future.
Yeah.
Like we were talking about, imagine if we could use this technology to make our cities cleaner and healthier. That's a pretty incredible thought.
It really is.
Yeah.
This research is a perfect example of how a deeper understanding of these complex systems, even something as seemingly simple as airflow, can lead to solutions that benefit everyone.
Well, this deep dive has definitely given me a whole new perspective on the world around us. It makes you realize that even the air we breathe is shaped by so many factors we don't even think about.
And with a little ingenuity, we can learn to manipulate those factors and create a better future.
Absolutely. So, listener, next time you see a factory or a power plant, just take a moment to think about that invisible dance of air and pollutants happening all around us. You might be surprised at what you discover.
Yeah, keep exploring.
And who knows, maybe you'll even be inspired to find your own solutions to make the world a little bit better. Thanks for joining us on The Deep Dive.
Until next time.